So we have a question where a box contains machinery that can rotate. The total mass of the box plus the machinery is 8 kilograms. A string wound around the machine comes out through a small hole at the top of the box. Initially, the box sits on the ground and the machinery is not rotating. Then you pull upwards on the string with a force of 133 newtons. At an instant when you have pulled 0.5 meters of string out of the box rises a distance of 0.19 meters and the machinery inside is rotating. That's a little terrible diagram I drew of it. So the forms of energy in the point particle system that are changing is just translational energy, and all these questions after it are for the point particle system. So we want to know what is the y component of the displacement of the point particle system during this process. And since we're just looking at the center of mass moving, so one point is just from here to here. So that would just be 0.9 meters. What is the y component of net force acting on the point particle system? So that's just the change in the force you apply to it plus the force of gravity, which is 54.5 newtons. So I'll work there. And now we want to know how much work is done on the point particle system. So work is force times distance. So we know that the force from the last question is 54.5 newtons, and the distance we know traveled from y is 0.9 meters. So that's 10.4 joules. Sorry. So what is the speed of the box? So we know that the only energy changing in the particle system is translational kinetic energy, and that's 1/2 mass times velocity squared. And we know that the work done from the last question is 10.4 joules. So we do 10.4 joules equals 1/2 times 8 kilograms times velocity squared. And from that we get velocity equals 1.6 meters per second. Okay. Now we're looking at the real system. So the forms of energy that change in the real system are translational kinetic energy and rotational kinetic energy, since we have the machinery spinning inside of the box. So, what is the distance through which the gravitational force acts on the real system? And that's just the distance the box moved, which is 0.9 meters. So how much work is done on the system by gravity? So we do force times distance. So we know that the force is mass times gravity, so that's 9.81 times 8 kilograms times the distance is negative 0.98 meters because gravity is pointing downwards, but we're traveling upwards, so it would be negative, and we get negative 4.9 joules. What is the distance your hand moves? So this is really easy. You just do the 0.45 meters you pulled on the string plus the 0.9 meters the box went up, so that's 0.64 meters. How much work do you do on the real system? So work, once again, force times distance. So the force we know from the question was 133 newtons, and we know from that the amount our hand moved was 0.64 meters. So that gives us the work done by our hand is 85.1 joules. So next question. Sorry. Okay. What is the rotational kinetic energy of the machinery in the box? So we have to assume that the work done by pulling the string is converted into rotational kinetic energy. So now we do the kinetic energy equals the work done by pulling the string, which is 133 newtons times 0.45 meters. That's just force times distance. And that equals 59.9 joules. So when the string has been pulled 0.45 meters, so that second part of the diagram, what is the total kinetic energy? So we already know that the kinetic energy is the translational kinetic energy plus the rotational kinetic energy, since those are those are the two forces changing. So we know the translational kinetic energy is 10.4 joules, and we know that the rotational kinetic energy is 59.9 joules. So we get 70.3 joules as the total kinetic energy Thanks.